Assalamu alaikum. Dear learners, I hope you are fine and doing great. In the introductory lecture video, I explained that how this course is going to go about and what are different things that I am going to discuss. Furthermore, I shared a brief and quick history that how automation started and is now influencing the industry around the world. In the last section, I explained various functions a production system has to perform and how automation may be implemented on those functions. In this lecture, I'll be talking about manufacturing operations on a broader level. So let's dig in. Manufacturing from the top can be viewed in two different ways. In the first way, manufacturing is perceived as a process in which a starting material is modified and influenced through the application of various processes using machinery, tools, labors, etc. And at the end, we have a complete product and some scrap or waste. This view is normally visible from the perspective of a blue-collar employee. However, from the perspective of a white-collar employee, manufacturing process is something that adds value to the starting material and produce a final product. What manufacturing processes were used and how they were carried out is not of any concern over here. The main point which is considered is whether value has been added or not. This view is also known as the economic view of the manufacturing. In this course, I'll touch on the economic view whenever the need arises. However, the main focus would be on the first kind of view. Therefore, to understand manufacturing operations, we need to take one step back and see what kind of industries are there so that we can relate the manufacturing operations with the type of the industry. Basically, industries are divided into three types, namely primary, secondary, and tertiary, also known as service industry. In the primary industry, manufacturing operations are performed directly on the naturally occurring raw material. For example, extraction of coal, metals, petroleum, agriculture, fishing, etc. The secondary industries are all the industries that work on the products of the primary industries and add value to it. For example, automotive, chemicals, electronics, plastics, and the list goes on. At the end, the tertiary industry, also known as the service industry, doesn't perform manufacturing operation on any raw material but act as a support industry for primary and secondary industries. It sometimes utilizes the product of secondary industries to support some other secondary or primary industry, for example, education, banking, transportation, etc. In this course, the focus will remain on the secondary type of industries where the actual value addition is being done. The International Standard Industrial Classification has classified industries according to the products that are manufactured in a particular industry. Broadly, there are two kinds of secondary industries. One is called the process industry, whereas the other is called the discrete product industry. In the process industry, the output is continuous. For example, chemicals, beverages, petroleum, power generation, etc. And these industries are given codes from 31 to 37 by the International Standard Industrial Classification. Note that although the output of the industry is continuous, but it is provided to the customer in discrete packaged form. For example, beverages in bottles, chemicals in containers, etc. On the other hand, the discrete product industry produces discrete output. For example, automobile industry will produce discrete number of automobiles in a given time. Aircrafts, appliances, computers, machinery, etc. are all products of discrete product industries. These industries are given codes from 38 to 39 by the International Standard Industrial Classification. No matter what type of industry we are considering, two modes of production may exist in it. The first one is called the continuous production, in which the raw material doesn't change and the process on it is carried out continuously to produce the output. For process industries, the input will be a continuous flow of the raw material, whereas for discrete product industries, the raw material will be discrete but will flow continuously. The other mode of production is called batch mode, and this mode is used when there is some variation between the final products to be manufactured. For example, At a particular time, a plant is producing one kind of a drink, whereas after producing a certain amount of that drink, the plant shifts to different raw material to produce a different kind of a drink. In short, manufacturing operation is carried out on a batch of raw material to produce a batch of output products. Manufacturing operations may vary from batch to batch to produce different products. Once again, both process and discrete product industries can use batch production in a way shown in these schematics. Talking specifically about the manufacturing systems, there are a number of things that qualify as one. In fact, all these things are being done either simultaneously or sequentially to achieve the final product. Basically, manufacturing operations aim to convert the starting raw material into a final product. Over here, it all depends on the product and industry that what raw materials are used. For example, for a computer chip manufacturing industry, the raw material would be silicon, small components, etc., which are packaged to form one chip. Whereas for an electronic appliance, the computer chip will act as the raw material along with some other things, and the appliance would be the final product. Anyhow, no matter what the industry is producing, the manufacturing operations can be generally divided into four different sub-processes. The first one is the process or assembly operation. Then there is material handling and storage operation. Along with these operations, inspection and testing is being carried out, and on top of everything, the operation of coordination and control is there. Processing and assembly operations are the most basic ones. These are the processes that change the properties of the input material, or we can say add value to it. In fact, processing and assembly operations are two completely different kind of operations. In processing operations, the workpiece is transformed from one form to a more desired form, whereas in assembly operation, we do move towards the final product, but properties of the input material are not changed. The only thing that is done in assembly operations is to assemble or join different components to form a single part. The tree diagram shown over here lists various operations that fall under the category of processing operations and assembly operations. You can see that all operations under the processing operations somehow change the physical properties of the material. These operations aim to change geometry of the workpiece, change the material properties, or produce a better surface properties through cleaning or coating. On the contrary, the assembly operations encompass basically two types of operations. Assembly of various parts into one complete part may involve either permanent joining through welding, brazing, adhesives, or permanent mechanical fasteners, or temporary joining through mechanical threaded fasteners. All manufacturing operations being performed on the workpiece fall in one of the type of operations given over here. Apart from the actual processing or assembly of the workpiece, the other major operations going on in the plant is the material handling and storage. Material handling includes everything from loading or unloading a part on the machine, positioning it for the machine, transporting it from one workstation to the other, storing it in the warehouse, or even waiting in the queue for processing also falls under the heading of material handling and storage. You would be surprised to know that in a case study related to a machine tool industry, it was found that a part spends 95% time in the state of moving or waiting, whereas rest of the 5% time was spent on actual machining. Even from that 5% time that is spent on machining, 70% time is taken up by the loading, unloading, or positioning process, and the remaining 30% is used for actual machining. So if I can further simplify things, you can easily see that only 1.5% time is used for machining, 3.5% for loading, unloading, or positioning, and 95% for moving and waiting. From this kind of time distribution, we can easily see where we should focus if we want to reduce the manufacturing lead time. Of course, if you try to reduce the time a part spends while waiting or moving, you'll have to upgrade the workstations, rearrange the layout, use optimal routes for movement of the parts, and so on. The third operation going on in a plant is of testing and inspection. This operation acts as the feedback for the quality of the products the manufacturing plant is producing. Sometimes online inspection is performed, that is, parts are being monitored and tested for quality while they are being manufactured, whereas sometimes the inspection is done once the part has been completed. Online inspection although requires more resources, but it can help in saving valuable time. A certain low quality part is rejected right away instead of waiting it to be completed and then checking only to reject it at the end. Normally, systems are incorporated in the manufacturing line that keep a check on the defined part parameters. The operation that combines everything in a smooth way is called the coordination and control operation. These operations doesn't only control the individual workstations but also coordinate and manage plant level activities. Activities starting from the proposal to the client till the final part production and delivery are all controlled through a central coordination and control system. So these are the four major operations that I have just discussed that are going on in a manufacturing plant. The operations just described are greatly influenced by the production quantity that is aimed by the manufacturing plant. Especially how the facilities are organized depends majorly on how much production is required. Technically, anything less than 100 units is considered as low production, whereas anything above 10,000 units is considered high production, and anything between these numbers is regarded as medium production. Almost everything in the facilities revolves around how much production is aimed. Generally, low production doesn't motivate fully automated systems, whereas high production is not achievable via manual labor. Furthermore, low production quantities mean you can have high production variety because it's easy to change the manufacturing system when few units are being produced. And if human labor is used, then exploiting the dexterity of human workers and industry may incorporate variety in the products quite easily. However, the same is not true for high production quantities. First of all, humans are not capable of producing large quantities, and secondly, dedicated automated systems are specialized to produce low variety or technically called soft variety products. This figure also depicts the same idea but using different terminologies. For low production quantities, normally manual job shops are utilized where mostly human labor is used, whereas for high production quantities, automated flow lines are used that are working at high speeds and are producing low variety or unique products. For medium production quantities, cellular manufacturing is preferred, as each cell is specialized in producing a certain type of product. In the upcoming lectures, I'll discuss in detail that what is cellular manufacturing and flow lines, or also called production lines. This was everything related to manufacturing operations. I hope you have fully understood what kind of operations are being carried out in a manufacturing plant. Thank you and take care.